Now, from the previous video, we learned that the atomic mass unit is defined as a 12th of a carbon-12. Now, in the first part of this video, we are going to use that definition to estimate the mass of a proton or a neutron. Now, what does the number 12 in front of carbon really mean? Yes, it indicates a specific type of carbon isotope, but it is also the sum of the number of protons and neutrons in that carbon atom. Now, any atom is made up of three components: electrons, protons, and neutrons, except for some hydrogens. Electrons are practically weightless compared to protons, and neutrons is about 4 orders of magnitude smaller than a proton or neutron, so we tend to ignore it. So now the atomic mass of carbon-12 is 12 Dalton. That mass is mainly made of the mass of the protons and the neutrons. We also know that protons and neutrons weight roughly the same, so let's assume that they are the same. So that will come down to 12U equal 12 times mass of protons. So the mass of a proton is equal to 12U divided by 12, which is 1U. Now, since 1U is a 12th of the carbon 12, so this is our estimation of the mass of a proton and neutron from the definition of atomic mass. So how close is it really to reality? So these are the actual mass of the proton, the neutron, and also the electron. As you can see, it's the electron is very insignificant compared to the other two. And I'm also giving you the atomic mass again, atomic mass unit again for reference. You see that if you estimate the mass of a neutron or a proton by 1U, that you are not actually that far off at all. And at the level that you will be dealing with in chemistry, that error is just very insignificant. Now, I have a question for you. So you know how a carbon-12 has 6 protons and 6 neutrons and 6 electrons? What if you add the masses of these particles together? Would it be equal to the exact mass of a carbon-12, which we know as this, 12U? So 6 times a mass of proton plus 6 times mass of neutron plus 6 times mass of electrons. Now that will come down to 12.0989148 U. Now that's not exactly 12U. Why? Why is the mass calculated by the addition of individual neutrons and protons and electrons to make up a carbon-12 bigger than the mass of carbon-12 itself? Now that difference in mass is actually called the mass defect, and it's due to the binding energy of the nucleus. I'm sure that you have heard of Einstein's famous equation E equals mc squared. It's E for energy, m for mass, and c for speed of light. In a way, you can say that mass is just a representation of energy. So the mass defect is basically just a representation of the binding energy, and vice versa, the binding energy is just a representation of the mass defect itself. So E equals mc squared. Now say you have your mass equal to 1 atomic unit, 1U times c squared. Now if you look up the speed of light and do the unit conversion, you will get a result of 931.5 mega electron volt. Now, 1U is worth 931.5 mega electron volts of energy. So the mass defect of that much is worth equal to 92.15 mega electron volts of energy. So it is indeed the case that when all these neutrons and protons and electrons come together, an amount of energy of 92.15 mega electron volts is released compared to when they were individually separated.